G'day, welcome to the Tech Math channel. I'm Josh. Today we're going to be having a look at ratios. So, what is a ratio? Well, a ratio is a way of comparing two or more sets of quantities. Let me give you an example of that. So say we were filling up a glass with cordial, with some Kool-Aid, and you can see here that what we do is we add the cordial to the bottom and we have three parts of that. Three parts of nice calm-inducing red cordial there, and to that we're going to add some water, and to that we add 8 parts of water. So 1, 2, 3, 4, 5, 6, 7, 8, and we dilute that down, and here we've set up where we have a ratio comparing the amount of cordial to the amount of water as 3 is to 8. So that at its most basic is a ratio set up there. You can also write them as a fraction, where we'd say 3 over 8 is, say the amount of cordial compared to the amount of water. But largely, ratios are set up and seen like this here. So let's get into some other parts of ratios, some important things that you should know when you are doing ratios. So the first thing about ratios is that measurements do matter. And what I mean by this, say we were looking at the side lengths of this rectangle here. We had ourselves a picture and it was 3 meters by 5 meters. Now the first thing you're going to notice is that we have the same units used here, where both measurements are in meters. And we need to have that when we are doing ratios. We're talking about the same units. So in this case, we already have things as the same units. I'll set a couple up later, or we don't. And so we can easily set up a ratio of one side to the other and have a ratio of 3 is to 5. What you're going to notice is we don't put those units down. I don't write 3 meters is to 5 meters. We just say the side lengths have a 3 is to 5 ratio. Because this could be in meters, but then we could also then talk about in centimeters or even inches, though those side lengths have that same ratio there. However, what about if I change this where we don't actually have the same units used? Let me give you an example of that. So say, for example, we had a 30 centimeter side on one side and a 2 meter side on the other. Now, and we're going to say what the ratio was here. You can see a bit of a problem because straight away we don't have the same units that are being used. So what you have to do here is very simply make it so you are using the same units here. So 30 centimeters I'm going to keep the same, but 2 meters I'm going to convert across to centimeters. There's 100 centimeters in a meter, so this is equal to 200 centimeters. Now I can write this ratio pretty easily. We have a 30 is to 200 ratio here. This leads us to one extra bit of thing here. Okay, what extra bit of work? This ratio can also be simplified. The third thing, or is it the second thing? Whatever, that I wanted to talk about here. As you can see, this ratio can be made more simple. If you can actually see a number that goes into both numbers here, you can reduce it down. So as you can see here, the number 10 goes into both of these. So we can divide both of these by 10. And when we do that, we get the ratio now as 3 is to 20. Cool, right? This can't be simplified anymore because we don't have any numbers that go into both of these that will reduce it down any further. But this is said to be simplification. When you're asked to simplify something, this is what you're asked to do. Reduce it down to its simplest form. Okay, we're going pretty well so far. What about we practice this simplification one more time and then we'll get on to something else. So say once again we had a rectangle where we had a 200 centimeter side and we had a 40 centimeter side, and we wanted to actually simplify the ratio that will form down here. Well, we can do that. So first off, write the ratio. This is 40 is to 200. We can write this because we have the same units both times. We can literally easily just write this as 40 is to 200. But now we can go through and simplify this. So look for a number that goes into both 40 and 20. And straight away you might say once again, okay, 10 goes in. So we're going to divide both parts by 10. When we do that, we get, okay, 4 is to 200 divided by 10, 4 is to 20. Now be very careful at this stage. Can any other numbers go into it? Can 4 is to 20 be reduced any further? And there is a number that goes in both of these. Well, a couple of numbers do, 2 does, but also 4 does. So we can reduce this even further by dividing by 4. 4 divided by 4 is 1, and 20 divided by 4 is equal to 5. And you'll know that you've hit the most simple form there if one of the numbers is a 1, or if you can look at both numbers and you know that there isn't a number that goes into both of these. So 1 is to 5 is the most simplified version of this ratio now. So now let's have a look at how to divide quantities into a given ratio. All right, so say we had $200. We're using 200, let's use it again, and we wanted to divide it into a ratio of 3 is to 7. That is to say, we want to give 3 parts of that money to one person and 7 parts to the other. We want to give 3 parts to our least favourite child and 7 parts to our favourite child. Well, let's work out how to divide this up. So the first thing we're going to do here is let's just look at the total number of parts that we have here. So 3 plus 7 is equal to 10. So altogether, we are talking about 10 parts in this ratio here. So now we get our 200 and we divide by that amount. 200 divided by 10, all up, each part is worth $20. That is each part. So we can divide up fairly simply now. One person is getting 3 parts of that. So 3 times 20, that person gets 60 bucks. Our favourite child, well, they're getting 7 times 20. That one is getting $140. So the money has been divided up into a ratio of 3 is to 7. All right, what about one more of these to practice? So we'll stick with the same sort of question once again, where we have $44 and we want to divide it up into a ratio of 6 is to 5. Okay, well, let's do this. First off, what we do once again is we see how many total parts that we have. We have 6 parts here and 5 parts here. So in total we have 6 plus 5. This is 11 parts altogether. All right, let's divide 44 up into 11 parts. 44 divided by 11, this is equal to 4. And this is each part is worth $4. Okay, all right. One person's getting 6 parts, the other person's getting 5 parts. We're going to multiply both of these by $4. So 6 times 4, this person here gets $24. 5 times 4, this person here is going to get $20. And as you can see there, 20 plus 24 adds up to 44. We've divided $44 up into a ratio of 6 is to 5. Anyway, that is the basics of starting how to do ratios. They're pretty simple, right? Don't overly panic with them. They are not that hard. Anyway, if you like this video, give us a big thumbs up and remember, leave us a comment telling me what the most inappropriate part of it was. And if you really want to support the Tech Maths channel, a big shout out to my Patreon, so you can become a Patreon. There is a link in the description below. Anyway, thank you for watching. I hope this video you found pretty helpful. See you next time. Bye.